So we established how to graph ordered pairs, and now we want to expand that a little bit into graphing equations. So first, let's establish exactly what we mean by an equation. Um, so if we have something like y equals x plus 3, this is an example of an equation, and what makes it an equation is that equal sign. So an equation is a statement that two mathematical expressions are equal, right? Meaning that what's on the left side is exactly the same value as what's on the right side. So, part of this equation, an equation doesn't necessarily have to have variables, but this equation does happen to have variables. Okay. So as the name suggests, a variable is a quantity that can vary. It's not necessarily just one number. It could be any number of things. For example, if x is 0, that's going to imply that y is equal to 3, because y is equal to 0 plus 3 in that case. If x is equal to 1, that implies that y is equal to 4, and so on. So they can have many different values. So because of this, that means that there's essentially an infinite number of values. So we want to create a graphical representation of what this infinite spectrum of values would look like. So let's go ahead and draw a graph here. And we're just going to make the tick marks, we'll just make them 1. So like I said in the last video, if you don't write anything there, it kind of implies that the tick marks all represent 1 unit, meaning 1. And another thing we can do then is we can make a table of x and y values. So like I said, the y value will change depending on what the x value is, for example, or vice versa. Typically, the way we would come up with an equation, or the graph of an equation, is we would pick values for one of the two variables and see what the corresponding values of the other variable are. Now, you can pick any values you want in this case because x could be any number, right? Sometimes in future equations, we might have some restriction on what x can be. For example, if there's the denominator and x is in that denominator, then we know x can't be 0. Or whatever value of x makes the denominator 0, we couldn't use that value. And that's because we can't divide by 0. In this case, though, what we're doing is we're taking the x value and we're adding 3 to it. Now, we can add any number we want to 3, right? We can add 1 to 3, we can add 2 to 3, we can add 3.45 to 3, we could add pi to 3, right? So it could be literally any number. So in order to come up with a graph, we're going to pick a few values and then kind of try to get a gauge on what the shape of this graph is. Okay, and as you do more of these and do a lot of different types of equations, you'll start to notice a pattern based on what the equation looks like. Okay, and then that'll make coming up with the graphs a bit easier. So I think a good starting rule of thumb is to do about 5 points and then see if we have a good grasp on what the equation looks like. And some good points to pick are typically 0 is a good point to pick. And then 1 and 2 would be the next logical values. And then we want to make sure to put a couple of negative numbers in there as well. Okay. So it's basically an arbitrary set of 5 points. You could pick any 5 points. You could pick, it doesn't even have to be 5. There's a lot of flexibility here. We're just trying to pick enough points so that we can get a good grasp on what the shape of the graph is. So if x is 0, for example, then this means that y is equal to 0 plus 3, which is 3, right? So y is 3. So this gives us an ordered pair that we can then put on the graph, right? If x is 0, y is 3. So 0 and 3 are kind of paired up with each other. Now we need more tick marks in this particular graph, right? Because I only had drawn 2, and we're going to need to go up to 3 at least. So to graph the point 0, 3, I don't think this is one that we really even looked at in the last video, where we're traveling 0 on the x-axis. So that means if we're starting at the origin, we're just not going to move horizontally at all. So we're just going to stay put horizontally. And then we're going to travel 3 units vertically. Okay. So that's going to put us right here. And we're going to put a point right there. So that's at 3 on the y-axis, 0 on the x-axis. So that's the point 0, 3. And then we just keep doing this with all of the points, right? So we get y, when x is 1, y is 1 plus 3, which is 4. Okay, so we're putting remember the equation, I'll copy it down here, is y equals x plus 3. So we're taking whatever the x value is we specified and we're putting it in for x. And then we're seeing what the corresponding y is. And again, just a reminder that these are arbitrary values. One of the most common questions I get about this is, why are we picking these numbers? How do we know what x is? And it's just because x can be anything. We're looking at this equation without any context, right? If we were looking at this in the context of a real world scenario, then maybe, it would be clear what the x values are supposed to be. But in this case, this is just describing a relation between two variables where you're adding 3 to one of them. And there's no limits on what numbers you can add 3 to. So x can be any value. So again, we can just pick whichever ones we want here. There's going to be an infinite number of them. We're just trying to get a graphical representation of it. And we can't look at all infinity of them, so we're just picking a few. All right, so anyway, let's go ahead and look at 1, 4 then. So we start at the origin. Let me use a different color here. So we go over to 1 on the x-axis, and then we go up to 4 vertically, and then that brings us to the point 1, 4. Okay. So I'm going to stop drawing these colored lines to represent that, because I think now hopefully it's clear how we graph a point. So let's go ahead and put in 2 now. And we'll get 5 here, right? So we add 3 to 2 and we get that y is equal to 5. So now we have the point 2, 5. So we're going to find the space where the 2 on the x-axis lines up with 5 on the y-axis. Okay, so that's going to be right here. And now we're going to look at the negative numbers. Okay, so y equals negative 1 plus 3 is going to be 2. So now we're going to negative 1 on the x, 2 to the y, and that's going to put us right there. And then finally we'll do y equals negative 2 plus 3, which is going to put us at 1. Okay, so we're going to go to negative 2, 1. And then, because I'm drawing it by hand, it doesn't look, perfect, but this does form a straight line. It should form a straight line. And by this point, that's hopefully, if you're drawing it okay enough, that hopefully would be clear. And because we're just looking at a few points, if we don't really know what the equation's going to look like ahead of time, this part can be a little bit tricky because, maybe around these 5 points it looks like a straight line. But then if we go out to x equals 10 or something, it starts to look completely different. So as we move through algebra, we typically will study different types of equations and what kind of graphs we can expect from those equations, what kind of behavior we can expect. So then we can be more confident in the values that we're picking and what the graphs are supposed to look like. So in this case, this is what we call a linear equation, meaning that the graph is a straight line. So we really could have just picked 2 points, because once you have 2 points, there's only one line you can draw between those points. And then we could go from there. I forgot to fill in the table over here. So let me just go ahead and do that for completion's sake. Okay, so this is the graph of the equation y equals x plus 3. So the advantage here is that, if we want to just really quickly think, okay, what is the y value going to be when x equals -3? Well, we can just look at the graph where x equals -3 and see that the y value looks like it's going to be 0. Right? Of course, because we're drawing it by hand, it might not look perfect, but it's a lot better when you use like a computer program or something like that, or a graphing calculator, and then it looks, you can tell perfectly exactly where that point is. So let's do one more graph here. So we're going to start fresh. So another common one to look at, because this one looks completely different, is y equals x squared. So remember, x squared, this 2 is an exponent, so this means x times x. So this is telling you how many times you're multiplying it by itself. Okay. So I'll go ahead and put the graph over here. Let me try to draw that a little better. And we'll make 5 tick marks this time. And put the arrows on the end here. And then we'll make our XY chart. And you don't necessarily have to make a chart, but it's a good way to keep track of the values here. And then we can pick those same 5 points. Now this is a completely different type of equation. Instead of adding 3 to the x values, you're instead multiplying the x value by itself. So if we just think about which x values we're allowed to use, we could still use any x value. You can multiply any number by itself, and it'll give you an answer. Things where we might run into problems would be like, again, if we have a denominator, we know we can't divide by 0. If we have a square root, we can't take the square root of a negative number. So things like that are what we want to look out for. In this case, you can multiply any number by itself, so we can stick with these points. Okay. So let's go ahead and plug in the x values and see what the corresponding y values are. So if x is 0, 0 squared, meaning 0 times 0 is still 0. So y is also 0. So we have a point at the origin, 0, 0. Now if y equals 1, if x equals 1, then y is equal to 1 squared, which is 1 times 1, which is still going to be 1. Okay. So at this point, it still kind of looks like a straight line. But we really need more points to make that call. So if we plug in 2 for x, we get 2 squared. So y is going to be 4, 2 times 2. And now it starts to deviate from that straight line shape. Okay. And now if we want to really get a good grasp of what this looks like, we don't have to write it down, but we can imagine what the next point looks like 3. 3 squared is going to be 9. So that's going to be, way above the graph that we've drawn here. We can kind of imagine it's going to start looking like this. Okay, it's going to keep getting steeper and steeper as we go up, because the points are going to be further and further away from each other. Now, on the other side of the graph, when we plug in -1, we got to be careful here. -1 squared is equal to -1 times -1, which is going to be +1. Okay. So negative times a negative gives us a positive. So this is the point negative 1, 1. Now I think it's important to really quickly, because this kind of comes up a lot, clarify the difference between negative 1 squared and negative 1 squared. Okay. On the surface, these look like the same thing, but we have to remember our order of operations here. So on the top one, negative 1 squared, this is negative 1 times negative 1. You do the parentheses first, and then you do the exponent, right? So everything in the parentheses is being squared. So you're doing negative 1 times negative 1. The second one, it's kind of like you're doing a negative and then times 1 squared. You're doing the exponent first. So the negative part is not being squared. Okay. So this is actually like negative 1 times positive 1. So it's negative 1. So this is another one of those common questions I get, a very common mistake. So it's important to really nail down the difference here between these two numbers, because if we're just writing out y equals negative 1 squared when we're doing the point quickly, we might write it down as the second one, and then we might come up with negative 1. So it's important to note what we're really doing here. And then same goes with negative 2. So let me move over. I can do it up here. Y equals negative 2 squared. Okay, we're squaring the entirety of negative 2. So we're multiplying negative 2 by itself. Okay. So we're going to get positive 4, negative times a negative. Okay. So, I think that's at 5, my mistake here. So we can see actually what's happening is that the left and right side are completely symmetric with each other. Because when we square the value, we're multiplying it by itself, so we're going to come up with a positive value. So 3 squared is going to be the same thing as negative 3 squared, and 4 squared is going to be the same thing as negative 4 squared, etc. So these are going to be mirror images of each other on both sides of 0. Okay. So this is a special type of graph called a quadratic, which comes up a lot, and we'll study on its own later. But this is a good example of how we can come up with the shape of a graph without really knowing anything about the equation in the first place. So we just kind of try to pick points and go from there.